There are 46 legs in a zoo exhibit. Every animal has either 2 or 4 legs. List 2 possible choices for the number of each type of animal in the exhibit. And then B, the number of 2-legged animals is 2 more than the number of 4-legged. How many of each are there in the exhibit? So let's do number A first, or letter A first. Let's assign a letter to each type of animal. So let's say that X is 2-legged animals. So now we know that whatever value we assign to X, you multiply it times 2 and you'd get to the number of legs for 2-legged animals. We're going to have Y for 4-legged animals. So whatever number of 4-legged animals there are, we'd have to multiply it by 4. And then realize by adding those together, we have to get 46. So we could have any combination of X and Y that works as long as the number of legs equals 46. Now I'm going to tell you it's better to assign Y a value than X. In that case, we'll never have a situation where it doesn't come out, so we have a complete 4-legged animal. You'll see as we go on what I mean, I think. So let's assign a value to Y. Pick any number basically, but stay small because we don't want to go over 46. We wouldn't want to. We could go as high as 10 or even 11, because 11 would give us 44 legs with 2 left over, which kind of almost gives you an answer to one of the questions already. We could have 11 4-legged animals, and we could have 1 2-legged animal, maybe 2. So let's even do that. Why don't we do that? What if we said that there are 11 4-legged animals? We still don't know how many 2-legged there are, but we know it has to equal 46. So if there are 11 4-legged animals, 4 times 11 is 44. That's 44 legs. So now the math becomes pretty easy. But let's just follow our algebra here. We know that 44 legs are accounted for with the 11 animals, so let's subtract those away from both sides to get 2 legs left over, and 2x equals 2 legs because 44 minus 44 is 0. What value would x be if we need to make this equation equal? So 1 times 2 is 2, so x would have to be 1 in order for that to equal. So now we just solve for the fact that x equals 1. So we have 1 2-legged animal, and y equals 11, and 11 4-legged animals, and that would work. Now why don't you try a different value for y, anything between 1 and 11, and see how many 2-legged animals you come up with. Alright, let's try letter B. Now, if the number of 2-legged animals is 2 more than the number of 4-legged animals, what would our combination be? So again, let's have the 2-legged animals be x. Let's have the 4-legged, no, let's not do that. Let's do this. The number of 2-legged animals is 2 more than the number of 4-legged. So let's go with y is our 4-legged, and realize that the number of 2-legged in this case is 2 more than the number of 4-legged. Alright, so now let's make this into an equation that we want. So we need to have 4-legged animals times that number, and 2-legged animals times that number, and if you add them together, we have to get 46. So you see what I'm saying here? We have y plus 2 because there's 2 more 2-legged animals than there are 4-legged. Now let's go ahead and solve for this equation. We have 4y plus, using the distributive property, 2y plus 4 has to equal 46. Let's put like terms together. 4y plus 2y is 6y plus 4 has to equal 46. Now let's subtract the 4 legs here from here, both sides, keeping the equation balanced. 46 minus 4 is 42. Now we know that 6 times the number of four-legged animals has to equal 42. So we're going to divide both sides by 6 and end up with y equals 7. So we have 7 four-legged animals, and if we had solved for x, or x still represents two-legged animals, we would have 2 more of those, which would be 9. So let's quick do the math. 9 times 2, let's go way over here, sorry about this, but let's go 9 times 2 legs to get 18. Let's go 7 times 4 legs and get 28, and let's add them up. 16, 2, 3, 4, and magically it worked. That is a hard problem for 6th graders to wrap their heads around, so just give it a try and do your best. That's all I can ask. See if you can solve for another possibility for A, though. I think that's in the ballpark. Thank you.